It was stick, and then I thought lightsaber. I was like, lightsaber. I got it.
That wasn't mine this morning.
You're also not well, you're not playing. I was not.
Oh.
Yeah. Are you on Portal?
I went to the website. Okay, we're gonna go through the second fundamental theorem of calculus. Oh, it's actually more fun because it's less work. Okay. And the fun gets bigger. Fundamental.
You should just like.
Stop telling me what to do. Ah. Okay, so what's happening? What is occurring? The derivative and the antiderivative are canceling out. I'm asking you, what is the derivative of the antiderivative of f? F. Why does that happen? Okay, so don't write this down, but let's take this right here. Okay, if we were to perform the first fundamental theorem of calculus on this guy right here, we would have the antiderivative evaluated from a to x. So we would have antiderivative at x minus antiderivative at a. Now we're going to take the derivative. Well, what's the derivative of the antiderivative of f? Normal f. But notice how there's an x in it because we did the first fundamental theorem of calculus. Okay. Now f of a, that's just a number. And what's the derivative of a number?
0.
Okay. So that's why a doesn't matter. Doesn't matter. Okay. That's literally it. Now, we cannot have a variable here the same as a variable here. So we have t inside, but when we perform the integration, it's going to turn to x, and then we take the derivative with respect to x. Okay. So, are you okay? Basically, this guy gets plugged in. You can do that? Let's try it. Those are my favorite. Write it down. Oh, is that not peanut? Oh, I ate the peanut ones. I'm with you. Hey, did you write this down? Okay, so notice how we have the derivative of the antiderivative. So we know those are going to cancel. And our integral goes from 3 to x. So a is just any numeric value. So we're good here. It's going from a to x. So what happens here is the derivative and antiderivative cancel out. The x gets plugged in. We have x cubed plus 1, and that is it. Do you want me to show you the long way just so you like understand?
Yes.
Okay. I'm going to do the long way, but if you want to ignore me, just don't make a fuss. Okay. So if I do this right here, don't make a fuss. Our antiderivative is 1/4 t to the 4th plus t evaluated from 3 to x. So first fundamental theorem, we have 1/4 x to the 4th plus x minus, when I plug in 3, we get 3 to the 4th over 4 plus 3. Now, I'm asking you to take the derivative of that integral. So when I take the derivative with respect to x, the derivative of this guy right here is x cubed. The derivative of x is 1. And the derivative of any constant, well, is just 0. Instead of having to do that every time, if we have the derivative of an antiderivative from a to x, we know those are going to cancel to be left with just what was inside. Okay. This is so fantastic. I love it. Okay. Oh, we're going to do plenty of things with it tomorrow. Okay. I would like you to write this down and complete the action. Do it. Do the problem. Matthew, what did you get? You agree with Matthew? That's good. That's really good. Okay. Write this one down. What do you notice? It's x to 7. That's different. I told you it needs to be a to x. This one is x to a. Well, that's not awesome. Okay. So remember when we learned all of those properties, in order to apply the second fundamental theorem, we need this to be a to x. So if I switch our limits of integration, that is going to make our expression negative. Okay. Now that we have a to x, our derivative and antiderivative can cancel out, and we have negative sine of x squared as our answer. Is that an honest question? Okay, thanks. Thank you. What is happening? Yeah. Good try. Write this one down. Okay, so me leaving for a couple days didn't quite help the maturity level. Got it. Okay, what do you notice differently about this one? Oh, there's the next cube. Okay, so here's the deal. If I ask you to take a derivative and there's something other than x inside, what must you do?
Change it. Make it X.
The chain rule is what Kylie said in sign language. It's Kylie's sign language, okay? I understood her. We have to use the chain rule if we have some sort of composition. So what happens here is the derivative and integral will cancel out. We're gonna plug in whatever we have in for t. But since it isn't just x, we do have to multiply by the chain rule. So we have 3x squared times the square root of x to the 9th plus 1. Let's go through that again. I have something other than x. So we plug it in for t, but then we have to apply the chain rule because we are taking a derivative where something other than x is inside. Hold on, All right. My youngest loves doing that. Really?
Yeah. Whoa.
So t became x. Light bulb. Okay, your turn. Find me the derivative. Find me the derivative of this function. I wrote it differently. It's the same thing we've been doing.
Change it.
Oh.
Who's your favorite class? Because it's obviously not us. She just agrees.
Like this, usually our teachers actually favorites.
I don't have favorite classes.
Except this, she's a except class. I don't have favorite paper.
I try really hard not to have favorites.
And then my mom. Is that when you have your next favorites? You don't like to It's always happy.
Is that the impression that they give you?
Yeah. It's almost 6 hours. Which already I mean, I would have been.
Okay, compare with your neighbor the answer to this problem.
We were playing tic-tac-toe the other day. Ooh. Yeah, I didn't even play it. You played like, at least I play it.
All right, Nathan. What is your answer?
My answer is 3x squared cosine x.
Isaac agrees.
I disagree.
Is there somebody who disagrees and has a clarification or question? All right, so let's jump back to the first fundamental theorem of calculus. Hey, this one I did capitalize. Okay, so that the second fundamental theorem of calculus, the antiderivative cancels out the derivative. We're left with the function. Okay, let's go back to the fundamental theorem of calculus, the first one, the fundamental theorem of calculus.
The fundamental or just the fundamental? How fundamental?
So we know that the derivative of x is 4x. And What's 18? Your answer? We know that f of 0 is 6. We want to find f of 3. Now, I do not want you to copy this down. So once you have written the problem, put your pencil down. Or pen, whatever you have. Just hold on. Okay. So at the beginning of the chapter, we did this. Well, f of x is going to be the antiderivative of our derivative, which means f of x is 2x squared plus c. And then we could plug in 0, 6 and figure out what c was, and then go back in and plug in 3. Or we can do this. Are you ready? This is what you're writing down. We know that the integral from 0 to 3 of 4x dx is the function value at 3 minus the function value at 0. What did I just do? The fundamental theorem of calculus, right? Okay. We don't have to worry about finding our plus c. What we can do is we can say, all right, I don't know f of 3, but I know f of 0 is 6. I know that the antiderivative of 4x is 2x squared, and we're going to evaluate from 0 to 3. So I have 18 minus 0 equals f of 3 minus 6. F of 3 is and that was way less work than finding the antiderivative and then finding c and then going back and rewriting the function and plugging in my value. Now, you can do it either way, except for when a calculator is the only way you can take an antiderivative. Okay, this gives us the option, since this is a definite integral and our calculators can do definite integrals. If I were to give you some sort of derivative that we can't find the antiderivative for, we would have to use this so that we could use our calculator for this left side. And we'll look at that next week. Okay, but I want you to practice doing this week. Okay. Why did I choose 0 to 3? Because I was looking for f of 3. Okay, so you're going to do this one. The integral you're going to set up, what are your limits of integration going to be? -1 to 2 is what I would choose. Okay, so at your pod, work together on this guy. Check your answer with a neighbor.
You're cold? Yes. It's cold. And what is that?
Have fun.
Hey, Matthew, what did you get?
I think at table one, you
Matthew, at table one, what'd you get?
I got 24.
You got 24? We have the same answer from the first problem? Oh, okay. Matthew from table 5, how did you set it up?
Oh, it's I said it.
Okay, and we know that f of 2 is 3. Okay. Over here, when we apply the first fundamental theorem of calculus, what did you say, friend? Well, if my integral goes from -1 to 2, then I need to calculate f of 2 minus f of -1. So unless you wrote these backwards, then this is how they need to stay for right now. But then we can do some rearranging. Okay, so we have 3x squared minus 2x to the 4th from -1 to 2. Oh man. Okay. 3 times 2 squared minus 2 times 2 to the 4th minus 3 times -1 squared minus 2 times -1 to the 4th equals 3 minus f of -1. Okay, so over here, we have -21. So -21 equals 3 minus f of -1. I don't know why there's so much checking. Quinn, I appreciate that you were explaining it to him. There's just like a lot of noise right now. Are we good? I can subtract 3 to get -24 equals negative f of -1. So f of -1 is a positive 24. Yeah.
Can you -1 and 2 and still get the right answer?
If you flip these two, then these two would need to be flipped and you'll be fine.
Oh, just making sure it works.
Yep, it will. So here's what's gonna happen. I have a worksheet for you guys. I know. And we have about 9 minutes left